Just as a wrap-up of the equations for rotational motion and linear motion, now for constant acceleration, we have the same equations. The only difference is that we are using different symbols. We are using Greek letters instead of regular letters. In this case, we use theta for displacement instead of x, omega for velocity instead of v, and alpha for acceleration instead of a. Another thing to remember is that these angular quantities, omega, alpha, theta as well, are related to their linear counterpart to the tangential quantities through these expressions. Tangential velocity is omega times r. Tangential accelerations is alpha times r. Length of the displacement along an arc is theta times r. Now, the radial acceleration, we know it as v squared over r, but since v is actually a tangential velocity, since v is omega times r, so we can write it as omega squared r squared over r. So that gives us this expression. So this is another expression for the radial acceleration. It's either omega squared times r or v squared over r. Either one of them would work depending on what we are given.